Here we're going to take a look at the three different methods that can be used to graph a linear equation in two variables. Given this linear equation, one possibility is to find values that satisfy this equation. So here we have a table where we will pick values of x. For example, let x equal 1, replace x with that value, and solve the equation. Performing multiplication first in this case, and then subtraction leaves us with a corresponding y value of 1 and the point 1, 1. So we'll plot that point. Picking another value for x, let x say equal 2, replacing x in the equation with 2, multiplying and then subtracting results in a value of 4 for y. So we have the ordered pair 2, 4, and we will plot that. It's always a good idea to plot 3 points in the event there was an arithmetic error. So again, we go back to choosing an x value, in this case -1, solving for the corresponding y value of -5, and plotting that point. We're now ready to graph this linear equation by selecting points. Another way of graphing a linear equation is to graph by its intercepts. In other words, where the line intersects the x-axis and the y-axis. So here we have an example of a linear equation given. First, we will find the x-intercept, and for a point to be on the x-axis, the y-coordinate must equal 0. We'll use that then to solve for the corresponding x value, letting y equal 0, and simplifying gives the following, and finally an x value of 4. Putting those points together, we have the ordered pair of 4, 0, and the point for the x-intercept is plotted. In a similar fashion, we can find the y-intercept by letting x equal 0. For any point to land on the y-axis, the x-coordinate has to be 0. So replacing x with 0 in our linear equation and simplifying, finally dividing both sides by 2 leads us with y equals 6. This is the ordered pair 0, 6, which is plotted, and connecting those 2 points, we have graphed the equation of this line by its intercepts. A third possibility is having equations in a specific form, which is referred to as slope-intercept form. The standard form for slope-intercept is y by itself on one side of the equation with a coefficient of 1, and having the x term and a constant on the other side. The coefficient of the x term in each one of these cases is the slope. So we can see in the first equation the slope is 3, 1/4, and -2/3 in the second and third equations respectively. The constant term is the y-intercept. In other words, where each of these graphs crosses the y-axis. In this first equation, our y-intercept is at -5. It will be at 2 in the second equation and at -6 in the third example. So let's use the slope-intercept form to graph this given equation. Identifying the components, because it is in slope-intercept form, the necessary component is that y is by itself on one side of the equal sign with a coefficient of 1. We then can determine the slope by identifying the coefficient of the x term. So in this case, the slope is equal to 1/4. Slope, as you will recall, is a ratio of rise over run. In other words, a vertical change per horizontal change. Next, we can also identify a point, and the particular point is the y-intercept. B has a value of 2, and a y-intercept always has an x value of 0 with that y value identified from this equation. We now have a starting place. We start with the y-intercept. Next, we'll move away with a slope of, again, in this example, a rise of 1 for a run of 4. where those two combine gives us another point, and we can connect those to graph the line. So here we have our final third option for graphing an equation of a line, which will come in handy when we turn to graphing solutions to a system of linear equations.